Okay, I think we can make a start. So thank you again for joining us. As I said, my name's Deborah Ives. I head up marketing for TigerGraph in EMEA. Welcome to our webinar connecting the supply chain dots. I'd like to hand over to the presenter this afternoon, Bruno Simic, who is going to take you through the webinar. Thank you very much.
Good morning, good afternoon, good evening, everyone. Thank you for joining our webinar, today's webinar. First, I would have some housekeeping items before we started. So you will be all muted, but you can ask questions anytime. There is a Q&A tab in the menu, so please enter your question there. And after I finish my presentation, we will have few minutes time to answer those questions. We are going to record this webinar, and the presentation would be emailed you as a PDF. And if you have any issues, you can also ping us on Zoom, and that would be in the background to coordinate this. So let's start with myself. My name is Bruno Simic, and I'm a senior solution engineer for EMEA at TigerGraph. I am for more than 25 years in the IT industry and worked for some open source database companies before I joined TigerGraph. You can connect with me on LinkedIn if you want. Here's my LinkedIn address. So then few information for all of you that don't know who is TigerGraph. So we are basically a company founded in 2012 in Redwood City in California, and been in a stealth mode until 2018 with our product TigerGraph. It is not only graph database, it is a graph analytics system. So it's basically analytics system with a graph database in the background as a storage. So what we are also good in is artificial intelligence and machine learning solutions, because we can provide this in database. We also have a SQL like query language called GSQL. So if you already know how to write SQL queries, you will be very fast learning GSQL. We are currently in all the cloud systems in the marketplace, and we have SaaS offering under TigerCloud.io. I'm going to show a small demo after this, which is based on TigerCloud instance. So, and we have some customers, of course, in various industries, but we are going to focus today on supply chain. And currently, our software, our system is in version 3.1. This is the last latest. So just to present you a small part of our expertise, we have now here these three verticals, and we are going to focus in the middle one. So what is actually beneficial for you if you start using graph analytics system like TigerGraph in supply chain would be capacity planning. You can cover material flow. You can do the all kind of inventory optimization. I will go into this part a little bit later. We also can support geo tracking and locations, and can do basically connect all this transportation vehicles based on the position. So it's not only a static transportation logistic chain, it is very, very dynamic. Of course, logistic warehouses, distributed networks, grids of all kinds. We have a use case in electric and gas supply. We also can use systems connected to IoTs, like, for instance, using MQTT protocol, writing the data, current data from sensors directly into our system. Also, digital twins, one important topic in supply chain. And on top of everything, using our technology, you can have predictive and optimized supply chain. So if we skip to the business values of using a system like ours, or our system, you will see here that what is actually happening. There is a forecast versus order supply impact. So what is actually here is if you have a sales forecast, so you can basically do this in advance. So supply can tool up. We have some minimal buying volumes because you can adjust your forecast to the sale needs. You can also dynamically change your forecast depending on the needs of the market. So think of what happened last year with as a COVID pandemic started, the car sales were actually going down for 70%. The whole travel industry stopped, so the transportation was stopping, and so on and so on. And of course, everything is basically focused on doing the optimization of your supply chain system. And this optimization, you can probably few of those things you can do in your current system if they are well connected, if you have a big machines to be very fast here, because those kind of calculations would take ages. But there are some things that you cannot cover with systems like this, and it is mostly connected to the risk. So basically, if you think about all those factors, that's just a few of them that we listed here, they're all connected to the risk within the supply chain. And it's a delay in delivery, it's unplanned logistic costs, transportation problems, utilization, assets utilization, so machine utilization. Also compliance and sustainability issues, because if we, let's say, use example of a food producing industry, they would have a lots of compliance criteria to cover, and if you cannot actually bring the information in your supply chain or in your logistic chain, then you could have a real problem selling your goods to the end customer. So this may be one big cost saving issue, because you can cut the risks, and it's not about preventing the risk, because the risk of if the assembly line is going to stop, then you cannot do anything with the software. But what you can do is you can recalculate maybe a different way or different parts how to solve this problem. Or you can, if you have, let's say, a problem with the delivery, so the supplier cannot deliver something, you can still track down maybe the possibility how to replace the component with some with other component which would fit into your product, and then sell your product. So this is how we can help in basically covering the risk. So this is nice to present, but what I would like to also present you is how our customers are using us and how we are helping our customers, because we are just delivering a technology for a solution, but our customers are basically providing this solution and building up. And there is a big, great car producer, which is Jaguar Land Rover. And what we did there was we actually solved some problems that they had. And there is the thing was that it was a real-time actually issue. So if you think that you need, even in a supply chain for automotive, you need some kind of real-time solution if, let's say, your production is having risks. So you cannot, even in automotive production, you cannot just stop the line, production line, or stop the painting part of your production, and so on and so on. So what we were actually doing there is bringing the whole system to the point that the calculation for optimizing the chain was done within 45 minutes, which is more or less real time in this kind of production. And the previous one was almost 12 weeks. So you can understand how big the impact in this planning was. And this is actually what we, or how the whole chain there is built up. So basically we have, it starts everything with sales order. So what is today, what is happening is automotive producers are not producing for salons. They're basically producing vehicles for customers. So it's basically after an order comes in, then there is a marketing feature, which is basically you select your roof or the parts that would not be a part of the base delivery or of this line of the vehicle. So it's some extras that you can order. Then you have this extras should be actually put in a car, because it's not the same system if you have, let's say, the roof, the glass roof on your car, because then you have to calculate the parts that you need for this. And then you order the parts, and the suppliers are delivering them, and you put the car together. So, and what we were able to do there was to define, or let's say pick out some of those three problems, or let's say focus on those three items, like answering historic blind spots, identifying tactical opportunities, and production optimization. And everything was based basically on focused on the risk. So the historic blind spot that was on the part supply part was which parts are most at risk of shortage after the latest change in a sales book. So this was not possible, or this is not possible with to solve with the current system in a performant and fast way. Why this? Because systems like SAP or Oracle, they are based on a premise that you go through history. Basically, you cannot do anything now. To be able to do something now, you have to get the data actually from a last second. So it's already history. And we have a possibility to do something based on predictions, and our way of connecting data is a little bit different. This is what I'm going to show you later. So on the other side, supplier risk, which orders are impacted by at-risk constrained suppliers. The classical example here would be you have two suppliers delivering you two parts, or delivering you one single part. But the problem is that those two suppliers would be delivered by a single company. So basically, you will be here at risk without knowing it, because you think if one supplier cannot deliver this, the other would could this deliver this. The problem have I think now the whole automotive manufacturer, because some of the components for the processors for driving units are not deliverable from Asia. So I heard that some of the car producers had to stop the factories for this, because they were not actually calculating the risk of there is only one producer of this single part, even if you have 5 suppliers that are delivering this. We had this tactical opportunities. What are other sourcing options for parts with a predicted shortage? So basically here you can, if you have the whole information of your chain, then you can calculate the shortage not based on just a single solution or a single part of the car, but on the whole production. And this is something that graph analytics system is very good at. The high risk with suppliers. Then the product optimization. So which parts should have their ordering levels changed on the basis of SOP scenarios? What minimum and maximum order levels should be set in the contract based on SOP scenarios? So those are the opportunities that we have. It's just a small part of it, and it's not, of course, everything. So since we already have a solution at Jaguar Land Rover, I would like to show you some slides, because I think this is nicely presented way of how multidimensional this supply chain management is. Even if you think a book of material would be very, very flat. So it is not multidimensional like something we have here. So it's basically here is how to define this line of sight between demand and supply. So you have two directions, and you have to coordinate demand and supply. So basically here is based on the features and the parts. So basically, because the feature can be actually, you could have one feature that has two parts that are connected with. And this is very, very complex topic that you can actually do only with a graph. Then the second one would be how to reduce supply chain risks. So this is the example with the what should I do if, let's say, somebody order a Evoque SE, and there is a differentiator in the features, and this is this example. It's a panoramic sunroof or fixed sunroof. So basically, what now would happen is you have the whole the possibility to go to all the features that one single car has, and you can get the suppliers for the part, and then you can basically check if how many parts depend on this supplier, and here in this example, how many parts is only provided by this one supplier. So these are the potential risks that you could have in this production, and this can be, I will show you later on, solved very nicely by traversing. This is basically this going through the graph technology. Then what we have here, demand supply graph for investigation and inference. It's a similar topic. So, but you see, it is based not on a single car, but it's based on a whole family of cars, on all the models. So basically, all the car producers have possibility to build, let's say, multiple cars, but lots of parts would be shared among them. So what you can do here is to you can basically use the graph to identify the features of a car that maybe is not sold so good at a certain moment of time, and you have some cars that are having a bigger demand. So what you could do is basically you could very easy then assign those parts to those cars which can be sold very easily. So that's the way. And then of course on other way, there are some also the possibilities to get the features or parts that are not used by a single car alone. Or on other side, of course, you can also do a negative search and say, just give me the parts that are used from a single car, and then maybe think about engineering that we can also change these parts into something that could work for maybe more cars than only one model. And the last one would be intractable optimization problem. So this is basically what is the profitability on the car if we change a feature of it. So this is here in a example evoked with a plain roof and with a sunroof. There is a something that is basically cost you money, and there is an impact of this cost because it is not only changing the feature, it is basically changing the whole connectivity in a supply chain, going through the parts and suppliers and so on and so on. So it's not just a change in a book of materials, it's a change in a whole process. And this can be done very on a graphy way. So to show you the second, the possibilities that we have here is basically you can start building intelligent supply chain with TigerGraph. And what you can do here with TigerGraph is you can track every individual part to entire life cycle from supplier to manufacturer to finished product. So in example with the car, it is you have a supplier. So I'm going to show you this in a moment, and all the parts, and you bring them together so you have the trackability. But also with if you're a food producer, for instance, coffee or cacao beans, you would like to know where they are coming, maybe how they are used to get let's say the lot of the specific coffee delivery was used to get you the grains, the coffee beans in this 1 kilo package. So what you can do here is go actually not only from one side, from left to right, and starting with the raw material and coming to the product, but you can also do the analytics from the product or even from the customer side and finish with the raw materials. So this is very open open system, which allows you to get the data insight from all the sides. And the benefits of it are it's a transparency, because you can actually see lots of things that you are not able to see, because I think this kind of presentation with connecting objects, it's much easier to read, and it's native to human beings than a table or Excel spreadsheet kind of presentation. Then what you can do here is a predictions. How this, because now we have connections and we have the objects, and based on those two items, we can actually play and say what would happen if I would replace one component and replace, let's say, for this component I have another supplier. Then I can play the whole chain from this component up to the product and see what are the impacts in the chain. I can also do some predictions to those connections, because for instance, if you have, let's say, two components are building up a third component, and you have a machine utilization, and this one machine utilization means it is time, it is energy consumption. So what would happen if, let's say, we can speed up the machine for, let's say, 5%, or what would happen if the cost of energy would be 10% higher? It is the whole chain. Then we can predict how it's going to change. Then you will have, if the data system is allowing this, real-time insight of the process. So think about, let's say, steel industry, and then you are making steel, and you have multiple stations. You have sensors, and those sensors would give you information about how hot the surface of the product is. So you can actually have the insight of the whole process here, and this in a real time. Then changes in the optimizations are very easy to make, but they're also very easy to be seen, because if you do, let's say, change of supplier and the component, you will see it visually, and you will not have to, like I already mentioned, go through the Excel spreadsheet type of a document, which is not very easy to find the changes. And then what we can do is also data-driven machine learning and artificial intelligence. There is just a better explanation for this in a few slides later. And what we can do is actually add a new dimension to the chain connections. Why this? Imagine in a case you have, let's say, a transportation chain. So you have a logistic chain. What you can do is you can define the value of the connection itself. So it would be, let's say, distance, or it would be fuel consumption, or it would be time, or whatever. And this is adding a dimension which is basically connected to the transportation way, or let's say to the connection itself, and not only to the objects that are depending on this kind of connection. And like in previous example, you can use machine utilization and put it there. You can use maybe how many hours of different people work you need there, and so on and so on. So it's actually up to you to define what you want to put in a transportation, and this is the new dimension. And you can see now supply chain looks like a graph. This screenshot in the background, it's a TigerGraph. So it's a natural way of connecting things. So from a higher perspective, if you stay with a supply chain for automotive industry, this would be a kind of complete chain approach. So what we can get is we can get data from supplier, we can get the data of different silos, because in an automotive industry, nobody is producing everything on a single spot. You will have one factory building chassis, the other would building bodies, and the third one, or even supplier, would build the engine. And then you put this together, and you have your sales spots, and you can get some quality control, because the customers driving cars would bring the car for repairs and so on and so on. So if you can get the data from all these, let's say, ways of changing the product, or parts of changing the product, then you will be able to get the full chain and see how actually where your biggest problems are now. Because in this case, if you have, let's say, just one silo, you will see all the problems that are connecting within this let's say it, ecosystem, but you will not be able to connect them with something outside. So how is actually everything working in a real life with us? There is so-called logical flow, because our system lives from data that you can deliver. And in this case, what we basically do, we first we have a differentiator between presentation, logic, and data. So the data is basically what we can get from the systems like SAP Oracle or some other supply chain management tools. And logic is then how we put everything together, and presentation is basically how to show you the results. What is also important is we are not exchanging or replacing your current systems. We are basically here just to improve the results that your current systems have, because they are built on a technology that cannot do what we can. And on the other side, what we cannot do is to replace a 20-something year of experience that somebody put in tools like this. But what we are very good in are to connect the data, to analyze the data, and the more data you have, the better result you are going to get. So the second step in, let's say, after the sourcing the data would be to get the data mapping. and to basically connect the source to what we need to be able to focus on the analytics. Then what we can also do is basically implement some custom algorithms or machine learning to enrich the set and connect everything. Then we can actually, then we will do our processing on the data that's already in our system. We have some possibilities to get the data out of TigerGraph. One of them is API or REST API. And of course, you can use then user interfaces on top of it. One of them can be, let's say, Tableau, or you can use Power BI, you can use exports to some other tools, or you can use one of our partners to make you a nice presentation system. And why is actually, let's say, we were talking about the benefits and how can we help organizing and be more productive and checking the risk, but how is it working in the background? Our system is based on it's a pure mathematics, basically. It's a graph theorem, and graph theorem is about connecting the dots. So there is let's say, an object, elements which are connected to each other, and these connections have a value. And based on how the connections are done, we can do some analytics on top of it. And on the first example is deep link analysis, which is basically how can I connect 4 different objects from A, B, C, D, and what is in between. So this would be basically the way to say, okay, show me all the parts from A to D, and basically include B and C in it. So one of the possibilities, for instance, in transportation would be to calculate the best way to get the data, or to get the product or component delivered, but taking in account, it's not only the distance, it's not only the time, it's also the cost. So there you have multiple parameters that you have to use here to be able to get a calculation of this. The second pattern would be a query pattern. So this can be used for example, if you have a system with billions of components, and you would like to have a component that is same or similar to the component you're having as a comparison, without need to program something, without need to make specific algorithms or change your system. Basically, the only thing that you need is the item that you want to compare, and the database itself, or this analytic system, would give you back all the necessary, or all the items that were found same or similar. And this is based on also on mathematics. So here you can use this, and some companies are using this to be able to track the parts which can be used as a replacement for something. For instance, when you're in automotive industry, you can deliver your cars with a tire, and or you normally deliver your car with a tire. So the problem would be there are specific elements that the tires has to have, size and so on. It's very easy to be done, but there is also index of the, I think weight index is one of the, speed index and so on. And there is also now for electric cars the tires that are very that are very light in a movement. So you will be able to find the same kind of tire without having need to use all the necessary connections that to program something new. So that's basically the idea here. Then you can also have in this relational commonality, you can find all the parts from A to B and see and check actually if your chain is maybe somewhere at risk because it's the connectivity between those two objects is not there. And there's a hub and community detection. It's more for customers and so on, but you can also use this if you're, of course, dealing with end customers, and if you're in B2C, and use this for your, let's say, customer 360 or improving your CMS, CRM solutions. And there are some others like time series and geospatial and machine learning and so on. So as I promised, there is more information about how to improve performance of the supply chain with artificial intelligence and machine learning. So basically, what you can do here is you can have machine learning that is going to be started or processed in database, and it is based on your data. So it's basically traversing the data, learning from the data, learning from historic data, and then giving you insight what could happen and what would be the optimization part, for instance, of this. And then, of course, you have some of these features that machine learning is based on. You can also only do with graph computed features, because this is actually one of the sweet spots of the graph database. And so basically what I would like to do now is to make a small demo. And for this, I would go to my, so this is basically my dashboard for TigerGraph Cloud. So everyone can register for free here. So this is the way to basically start with TigerGraph without having to install anything. So if you go and create solution, you can select one of the starter kits. So we have 20-something starter kits, and you can filter actually on the topic. So I would say what we have here, what I did was actually I took supply chain, go to next, and then you can take this TG3. And TG3 is the instance which is not costing you anything. It's really free. The only downside is if you're not using it for 1 hour, it's going to be stopped. And if you are not using it for 1 week, it's going to be terminated. That's it. So when you start this, what I already did, then you get something like this. This is my demo graph. So it's my solution, supply chain management solution, which is giving you the possibility to do something with it and to play with the graph. And what I can do here now is I have the data. So basically the data would be mapped to graph. Now here in this case, it's just in CSV files. The data is loaded into graph. So it's not a big graph. It's just for playing with it. And then we can explore it. So what I can do is here, I can take, let's say, yeah, let's do, there are only 2 orders. So basically I can take 2 orders here, and I can double click on one order and then see, oh, this is a track wheel set. So if I click here again, then I see this track wheel set is basically done on a site 1, so produced in a site 1, and it would be delivered from site 2 and site 15. And then if I go to site 15, I see that basically here is the connection then, because site 15 delivers truck rims here. And if I click on this truck rims, then I see that it's an assembly, and there is a steel roll rods and so on and so on. There's an ABS module. And here is how actually the whole graph is now done. And it's a nice thing to do, because you can click through, but it's not very performant. So it's more or less for somebody to see how the data is done, and and it will be more on data analyst and developer side. But what you could do actually is also to write some queries. And the query, let's say, for showing the whole graph would be something like this. And then if I go and show the force the graph, and then let's see here a little bit bigger. So you see all the connections, how they're done from the rubber supplier, then goes to rubber, then it's used for tires, and then the tires are used by wheel set, and there are some belts that are actually as a component for the tires, and so on and so on. You see here different colors for different type of objects. So the sites are basically factories, and I can go through this system. So what I could do is also let's check here. So if I go here and do let's say find paths, I would like to have a path between sensor and car wheel set. So I could do one shortest path or all shortest paths. Let's do all shortest path. And if I click here, I see there's no, okay. So basically I was just, it's a little bit not so perfect. Let's do one. So you see there is a car wheel set is used by Reams, and then we have ABS model, which is produced here, and then it's the, okay, my browser. So you see here, this is the path from the sensor to the car wheel set. Or if I do, let's say, all shortest path, then let's hide this one, result, and this result then would be actually, you see how they are connected. So this is my sensor, this is my car wheel set, and they are connected over TPM assembly and so on and so on. So this is actually how TigerGraph analytics system can help you with your existing data. Or we can actually check stocking sum here. Let's say this would be basically based on a data that we have here in a database. So let's see, I would like to have 10. So, and then see what is actually happening. I see how many parts actually would need here, need amount consumed, his in stock amount, and so on. And the result is you can actually have this result in this visual view, which you can a little bit go into it. But normally you will consume this with as a plain JSON format, and you can use some of the BI tools to parse it and even use it for your existing application. So this would be basically everything that I planned today. I think we are just in time, 45 minutes. So let's check the question. Okay, so the first question is digital twin just a novel way of saying scenario planning? Is what you are doing in terms of minimizing risk, effectively process modeling with quantification. So basically, the fact here is digital twin is, yes, it is a plan of it's a scenario planning, but what is also happening if you have a very complex system, then you cannot do a proper checking if your expectation and your delivery are in sync. And this is one of the ways, if you have using graph database, don't forget we are talking about real time, then you can actually check if everything is fine, if all the components are in your threshold that you actually define in some kind of scenario in front. And then if not, then you can do alert. And this is not a very specific for a graph system. You can do this with any other system, but the more complexity in the chain is, the less real-time the whole thing would be, because you cannot go deep into system. And like we saw, it is very connected. So that is the way that why we are putting this digital twins into it. Okay, can you talk about deployment times when there are changes in the schemas or arrival of a new data which needs inclusion into the analytic workflows? So basically, what we do is, the first question would be how the data is coming in. If you have, let's say, batches of data, then you're not doing actually real time. We can use Kafka to ingest the data. And then what we do is normally we have the ETL process. So we can use the ETL process to assign the data to the actual objects. Or we can do some kind of machine learning process on top of it, which is automatically checking the schema and applying this new schema to the graph system. So curious if you also have a representation of time throughout the supply chain graph, which stars are used to produce and evoke may change over time, different time model, different manufacturer, etc. Are you able to run scenario planning that incorporates dynamic future state plans, not just current state? Thinking about time-dependent bills of materials, for example. Yes, because okay, in this case, what we have here as an example, we are basically missing I would say the stock kind of table, and what we have here is we can put this the information about time frame next to the material. So the prediction is not only based on a current state. The prediction can be based also on a future state if we have the data for this. And we can also do some machine learning procedures to basically dig through this and drill the data through. Another question: how can you able to come over the challenge of bad input data, wrong data, legacy system data? Great question. Yes, what we can do is basically, since we are not depending only on the ID, so basically the graph database, a system of assigning data and relations should not be based on IDs only, like in a relational data model. So what we can do is when we do data ingestion, we can use, let's say, similarity search and predict, even if the data is bad, what components is basically hiding behind this, because we would have hopefully some historical data that was okay, or let's say some data that was that would be used as a learning data before we start entering this. If we start entering bad data from the beginning, then it's a known problem with a garbage in, garbage out. So we cannot change this here. What do you think is the biggest difference between using graph for supply chain analysis versus okay, Tableau? So what we do is basically Tableau is not an analytic system. Tableau is basically just a visualization part of it, and Tableau cannot do deep data diving like our system can do. So basically, the whole idea is, and that's why I said at the beginning, we are not a graph database. We are a graph analytic system having graph storage in the background. Is you combine those two features and get the data to the visualization part of the system. And this visualization part of the system would mostly be something that is very flat. It's not very dynamic, and it's not going to be very performant in processing the data. Okay. For patient management, do you have use cases which were used to build a TigerGraph for Customer 360 analytics? Yes, please contact us. You have my LinkedIn. You can also use our contact form, and we will be glad to send you some better documentation about this. That's it. If I use your portal to log in, will I find some sample studies and graphs in Customer 360 for patient? Yes, there is. I think, just for a second, share my screen. If you go here, you have under my solutions, let's create a solution. We will have something like healthcare. So you have referral networks, page rank, community detection. This would go into this, I think, direction a little bit. And then we have here Customer 360 attribution and engagement graph. So basically, it is not connected directly to healthcare, but we have a huge customer in USA using us for Customer 360. And I have even colleagues that are better informed about what they did there. So contact us and we are going to send you the information. Okay. Hello, I study ECT in Tunisia. I suppose it would be nice for me to get the internship for TigerGraph for next summer. Okay, Joseph, you have my contact data. Just send me everything that you can share with us, and I'll get back to you. I think that's it. Oh, we're fast. So I'm done, I think.
Yeah, I think those are all the questions. Thank you very much.
Oh,
yeah.
Okay.
So I didn't know if you had another slide to share, Bruno, just with some links where people can kind of get more information.
Yes, sorry, I was too fast. Yeah. Okay, so basically, you can try TigerGraph Cloud. As told you, we have Enterprise Edition, which is 50 gigabyte free space. So basically, it is a license, but it's free for 50 gigabyte raw data. With our compression, you will probably be able to save something like 75, 80 gigabytes in it. Just send us a request or fill in the request for the download, and then you will get it automatically. You can also use a Docker container with a basically same setting. You don't need to install anything. You just pull it, and that's it. There is a link to test drive and online demos. You can do a certification on TigerGraph. We have a nice program with a so-called GSQL 101 and 102. And you can also join the community. So if you have, if you want to follow us, there are some Twitters, and we have a YouTube channel. There is a Facebook, and there is a company LinkedIn you can follow. And you can reach me if you want. I didn't put now my contact, but it's bruno@tigergraph.com. And I think what we also have, and maybe it is very interesting for lots of you people, is we have Graph AI Summit, which would be on April 21st and 22nd. We have a free registration, and we have, in a moment, call for speakers, which will be open for the next 20 days, something like this. And you can join here. You can apply for a speaking slot. I would be glad to have you on board. And that's it from me. And what you're going to get is the PDF is going to be sent to you, the download link for it. And like I said, just if you have any questions, ping me on LinkedIn, contact me on email. I will be glad to answer as soon as possible. So thank you very much.